Okay, so we are going to be learning to determine the rule for a graph of a polynomial. So this is currently working through 4G from the Unit 3 and 4 Methods Cambridge textbook. So whenever we are determining the rule, you need to know all the possible ways we could write the rule and then be looking at the information that you are given. So there are three forms that you could find. The first is the standard form, and this is where I would use this when I'm given random points. If you're given an point and one other point, I will be using the inflection form. Or if you are given the in factorized form where you are told all of your x-intercepts, then I'll be using the factorized form to help me. So again, it just depends on whatever form we get. So because this is something we do with every function, I'm only going to do two examples, and it's about determining what is the appropriate form. So here, we're going to determine the rule if there are x-intercepts at -4, -2, and 6, and it passes through 0, -4. So the first thing we need to do is determine the appropriate form. So we are given the x-intercepts, which means we must use the factorized form. I'm just going to substitute the x-intercepts in, and that gives me y is equal to a in brackets x plus 2, x plus 4, x minus 6. The final thing I need to do is find a. To find a, we need to use the final coordinate. Our final coordinate is 0, -4. So it's all about, if we plug that in, we will be able to find our a value. So I can simplify this to a times 2 times 4 times -6. 2 times 4 times -6 is -48. And then I get a by itself by dividing everything by -48. And I get a is equal to 1 over 12. I just grab that a value and place it back into that equation. And I get y is equal to 1 over 12. X plus 2 in brackets, x plus 4 in brackets, and x minus 6 in brackets. With this next equation, we've got to determine the rule for the polynomial that passes through 0, 3, -1 and 3, 1 and 3, 2 and 15. I want us to determine the appropriate form that we're going to be using. In this case, they are random points, so it would be easy to use standard form. So I'm just going to plug in everything into ax to the power 3 plus bx squared plus cx plus d. The first step I'm going to do is just get rid of the d value, and that's because I know the y-intercept and d would be a constant. So that straight away tells me that I can use the first point, 0, 3, and just say d is 3. The next part is you need to create equations for all the other points. So I've just written 1, 2, and 3. I'm going to substitute -1 and 3 into the first equation. The second equation, I'll substitute 1 and 3. And the third equation is substituting 2 and 15. So I've substituted everything in. Now it's just about simplifying. So this first equation will just be 3 equals -a plus b take away c plus 3. I can simplify that by getting my 3's to one side, and this will be the one I use as substitute, so I will get c by itself. I will simplify the next one, so this turns into a 1 squared is 1, so plus b plus c plus 3 is equal to 3. Same with my third equation, 2 times 2 times 2, which will be 8a plus 4b plus 2c plus 3, and I can simplify that down by taking away 3. So now we've got three equations. We're just going to substitute the first equation into the other two, and that will just allow us to eliminate one of the variables of c. So let's create two equations. So first, I'm going to grab 3 equals a plus b plus c plus 3. I'm going to grab this what c is worth, which is negative a plus b, and I will substitute that in. So that will give me negative a plus b there. I can simplify this. A take away a is cancelled, and b plus b is 2b. If I get b by itself, I take away 3. Now this straight away tells me that b has to be 0. So what does that mean? It means I've got nothing for bx squared. So I'm just going to substitute b equals 0 into the equations. And I get c is equal to negative a. And I also get 12 is equal to 8a plus 2c. Now we're going to use our simultaneous equations. So because I know what c is, I can just plug that in straight away. So that means I've got 12 equals 8a plus 2 times negative a. 2 times negative a is negative 2a, so 8 take away 2 is 6, so I've got 6a. That means if I divide both sides by 6, I get a is equal to 2. Okay, now I've got this. I can then find out what my c is. So if a is 2, then c must be negative. So negative 2. I've got my values, I plug them straight in. So that gives me 2x to the power of 3, take away 2x plus 3.